Hey guys, welcome. So in this video, we're going to find out how we have managed in our code to say that we want an array of integers called layer priorities, and yet using a custom editor script, we can actually pick from Unity's proper layers, and they get stored as integers, but they get presented as human readable layers, which are the same as the layers up here. No layers in two places. This is just one single layer. We're also going to see the dark side and difficulties with custom editors in Unity. So I look forward to diving in and seeing you there. Let's back up a moment and just make sure we're fully clear on why we're even making a custom editor. So I'm under source control here. I have GetKraken, which is a Git-based system, and I can safely just delete this Camera Raycaster editor script for the moment. I wouldn't bother if I were you doing that because we're going to be using it. I'm just going to show you something. If we didn't have a Camera Raycaster editor script, then let's take a look at how the main Camera Raycaster component would look. It would do exactly what we've said in the code. Remember, in the code we've said expose an array of integers called layer priorities, and it would be right there. And we could simply come in and say, well, the priorities are layer 9, then layer 8, and we could refer to the Unity layers window, and that would tell you that that's walkable and then enemy. And that's kind of okay. But I wanted to do better than that. I wanted to provide you with the ability to actually select the layer here. Now, it does come with some downsides when it comes to custom editors. By the way, custom editors are not the only custom things that you can do in Unity. We also have editor windows, which produce results like this, quite complicated editor windows. We also have something called property drawers, which we'll explore later most likely, and they are just for single properties. We have a special property like this, ingredient unit, and they can be pretty interesting, and especially in an RPG. But we're talking about custom editors. Now, the thing with a custom editor is you have to replace the entire editor for that particular object. So now if we are making a custom editor for the Camera Raycaster component, then all of its properties need to be drawn by us in code. That's one of the disadvantages, but it's worth you learning it. So here is a standard Unity editor for an array of integers. You have a drop down, and then you have an indent after the word layer priorities, and indented is size and element 1 and 2. When we write this custom script, which I'm going to talk you through in a minute, if we just discard the changes in source control, then it'll take us back to where we were, which is with an editor folder. Now, by the way, an editor folder is a very special folder. That's where you have to put editor scripts. And then I'll talk to you about the format of an editor script in a minute. But I've called this editor Camera Raycaster editor.cs. If I just play the game to kind of refresh it, then you can see here now, this looks identical, but that's only because I've made it look identical. It's not automatically identical like this. I've forced this indentation and tried to make this look as similar as possible. And what this thing is doing now is it's presenting you with the actual list of layers, the same as you would get from Unity's menu up here. All right, and what it's doing is it's actually storing that still as an integer, so the code hasn't changed. The code is still saying, I want an array of integers, but what this provides us with is an interface for setting that integer. So that's the purpose of doing what we're doing. And the other purpose, of course, is that you learn a little bit about editor scripts. Cool, so that's it. That's why you'd want to do it in this particular case. Now, we're going to review Camera Raycaster editor.cs in some detail and see how it works. And then, of course, you won't learn anything unless you do something yourself. So I'll make a little challenge for you. It's a banal challenge, but it's a really important one. So here we go. What do we need to do to make an editor script? Well, here are the most important things to note. Firstly, the namespace you're going to need to import is Unity Editor. You don't need anything else normally apart from Unity Editor. None of the Unity engine or system or any of this stuff you normally see, just Unity Editor. The other thing you'll notice is your classes normally inherit from MonoDevelop. So over in Camera Raycaster, we'd inherit from MonoDevelop. But in the case of an editor, whatever you call your class doesn't really matter. You must inherit from editor. Okay? Then you go about operating inside a onInspector GUI method. So that is the method that will be called every time that this GUI over on the right-hand side here, or the inspector GUI in general, is called. Every time that's called, which you can find out, by the way, you can always find out when things are called in Unity by going Unity execution order. And if you look for that, the manual under execution order of events, you will see in here that we have our start. Let's just pick out the salient points, then the update, and then you will also see somewhere that you've got on GUI. And that's all the GUI rendering and you've also got your editor scripts. There's lots and lots of different things going on inside Unity's execution flow. All right, so we're talking about GUI events here. So back to the code. So what I'm doing here then is a general thing, is I'm saying at the beginning and the end of all your editor scripts, you need to write these two things. You need to start by saying serialized object.update. So what that does is it serializes the instance of the camera raycaster at this point. So we're sitting here in the inspector, the game's not running. It serializes the camera raycaster object. What does that mean? It means it puts it into a format that can be put on a disk in something like a JSON file. It makes it into a savable format. So you serialize. Then you go to work and you do some stuff on it in memory. And then you apply the modified properties back to the serialized object. All right, so this is how we make changes. We serialize the raycaster, make changes to it in memory. They don't do anything. They don't change any of the values of the actual instance. And then you apply the modified properties back. All right, so that's the general pattern. Then looking inside, this stuff here is just painting the UI. And then it has a couple of helper methods to help you to actually do the job. So what are we doing here? Well, you have to literally do everything step by step. I start off with a member variable called isLayerPrioritiesUnfolded. This is a Boolean. It starts off as true, which means that this drop down here is going to be unfolded by default. But just putting isLayerPrioritiesUnfolded equals true does nothing. It's just a Boolean. It does something because of this. We set the value of the Boolean to the result of asking the editor GUI layout .foldout. You say, call this method, provide a label called layer priorities as a string, which is this string here. And if I'm to toggle this, by doing so, I'm switching the output of this whole method, and I'm storing that output in this Boolean outside of the on inspector GUI method. So what this is saying is this detects changes, or this actually doesn't just detect changes, it actually presents this foldout here, this layer priorities foldout. That very line presents the foldout. Without it, we wouldn't have it. And it returns the current value of the foldout, and then we store it so that that value is consistent frame to frame. If we didn't store it, well, let's just try not storing it for a minute. Let's just try popping, for example, a comment here and just calling the editor foldout. Let's see what happens. Just let it compile. What happens is you can't actually do anything with it. Okay, it's drawing it. This command is drawing it. The return value is being thrown away, and then there's no way to change it because it just continues to set the value to foldout as true, and true never gets changed. If we watch what happens to isLayerPriorityUnfolded, because I've commented out this line, it never gets changed. Okay, so the idea of saying equals is actually doing two things in one go. I hope that makes sense. It's drawing it and it's setting the value. Right, next thing you do is it says if it's unfolded, then indent a level. So if it's unfolded, which is in this case now it's unfolded, add to our indent level. This allows us to use this code anywhere, and it's relative indenting. So if you're going to add to the indent level, you ought to remove from the indent level at the end to leave things where you were. Then just paint two things. Number one, paint the array size, bind array size. And we'll talk about how that works in a minute, but that draws this line, the size line. Then bind array elements, which goes through the array, whatever size it is. If I set it to 5, it does 5. If I set it to 2, it does 2. Behaves just like you would expect in Unity. And we need to put enemy over walkable, and it gives you this type of functionality, all right? And you unindent, and then you apply the changes. Good. So that's that. Hopefully that makes some sense. This is the process of every single frame. So every time there's an update here in the editor, which is happening very regularly, this is literally, functionally, statelessly, just reading everything from the instance, creating a fold out and keeping track of whether it's folded out or not, and then if it's folded out, indenting, drawing every frame, every update, the size button, and then the elements. Okay, so that's that. Now, how does it draw these things? Well, let's look at bind array size. You take an integer. Now, this is weird. You go serialized object.find property. Now, to find the properties of the serialized object, remember that we serialized the object up here, all right? and we're inside an editor class, so that's why we have access to this serialized object thing. It's available everywhere in this editor class, this property. We go and find the property, interestingly, by a string. We have to form a string. And the way that we find layer priorities, which is the name of this variable here inside the camera raycaster, is you say layer priorities dot array, because it is an array, dot size. And then what we get out of that is a string, which we need to translate to an int value. Remember, these serialized properties are just text files, effectively. All right, so then you say, well, that's the current array size. That's what it currently is inside the camera raycaster. What are we asking it to be? What's the required array size? Well, to get that, this line here paints an int field called size, this thing here, well, labeled size, and it puts into that field the value of whatever's currently stored over in the instance. So the instance started off with a default of 2 different layers, or the last time it was updated, it had 2 layers, priorities. So that's what we're ending up with here is 2. And it takes the result of that painting to the GUI and stores it as the required array size. And then it says, well, if the required array size has changed, what does that mean? That means I've done something like this. I've gone from 2 to 3. That was the required array size changing. If that happens, then go and find the new value of the array size. Then in this case, set the same thing we had up here, this serialized object find property. If we find that, hang on, if I do a find on that without the semicolon, you'll see. We go this time, instead of finding this value that's in the serialized object, we go and set the value to the required array size. Only in memory, remember, because remember we have to come out of here and apply back to the object, but that will happen very, very quickly. So I set 3. It notices it's different. It creates us a new array element. So I set 3 over here in the inspector, and then the figure changes. That's the point. The number changes. These layers is a different thing that happens down in the bind array elements. So how does bind array elements work? Well, it's a very similar thing. It says, go and find me what the current array size is, this thing here, which we're using all over the place. And then loop from index 0 to the array size, doing the following. Finding the property of the array data. Now this thing, look at this. This is horrible. But it's necessary if you're going to do these custom inspectors. What you're doing is you need to form a string to find the property. But how do you find the property of the element of an array? Remember, this is how we found the array size. We said layer properties.array.size. We need to say as a string, layer properties.arrays.data, and then in square brackets, a number. So this thing here is a format operator, which says, well, go and get your number from the index I here. So the first time around the loop, it produces this. Let me just show you in a comment. The string it produces is data array, blah, 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 0. When I equals 0, then I equals 1, 2, 3. That's what it's doing, okay? That's what it's producing using that format operator here. And then it goes ahead and creates a layer field, which is this thing here, this layer field. And again, it uses a format operator. So it says, go and get me layer, and then use the I to populate it. So layer field, if you go and look it up in the docs, is something that's going to present you the list of layers, and it's going to iterate through the layers, printing out based on the I value. So it's kind of weird and minging, isn't it? We have to be producing all these strings and all this sort of stuff to get it to work. So they're not great, but they're pretty powerful. Now, actually, these days in Unity, there's an argument for using something different, which is called property draws. But I want to show you how these work. You'll see them all over the place, and it's important for you to know how they work. So I don't know how well you've grasped this, but let's find out. It's a different type of programming paradigm. What I want you to do is add a string to the editor. We're actually going to remove it again afterwards, but this will test whether you can use this stuff. Label the field and give no indentation, and in the end, it should look like this. So I'm just going to put a 0 indentation. Notice that this is the same layer of layer priorities. If we folded layer priorities up, it'd sit right underneath it. Label it what you like. I'm labeling mine string to print. I've got a string field. And what we want is that when you enter into that string field, you see this stuff happening. Every key press, it updates. So you're going to need to print out from inside camera raycaster.cs's update. I'll do it for you now. Just print. Actually, let me just get you off the ground. I will just start this beginning. so that you only have to operate on the editor script. So this is what I mean, just to make it clearer, because otherwise you're kind of guessing what I'm asking you to do. So I'm saying have a serializable field over on the camera raycaster. Call it a string type, and let's just call it string to print, okay? And then, so that's fine, and that would just appear, well, actually, firstly, that doesn't appear in the editor, because as I said, when you have a custom editor, you have to recreate every item of it. Anything I add in here is not going to appear unless I explicitly code it into the custom editor. That's the disadvantage of a custom editor. It's all for one. You have to just replace everything or nothing. That's different to property drawers where I can replace a single line, but we'll see that later. All right, so string to print does not appear. If I then go ahead and print string to print, like so, on every frame inside Camera Raycaster, there's basically no point in doing this apart from you're learning how to use these guys, right? If we do that, it does not appear in the inspector. If we click in the console, we're actually getting a blank coming in here. And why is that? Because we never initialized string to print. We should always initialize these things. So I'm just going to say new string, like so. And now what I'd hope is that when we play, or even when we don't play, we get, well, no, we need to play because the Camera Raycaster is running at playtime. And now it should be saying new string. It's not for some reason. What's wrong with that? So interestingly, that's not printing. Let's try removing serialized field. So we just have a private string to print, and we print it out. This is nothing to do with editor scripts right now. We should see new string coming in. We do. So it's interesting that if I make it serializable, that the fact we have a custom editor is already messing with this. You see what I mean? Once you commit to a custom editor for a given object, like Camera Raycaster, you've got to go all in. So if I put that serialized field back in, we get slightly unexpected behavior. We get nothing printing here. Okay, that's fine. Anyway, that's what I meant by you need to be printing out every frame, whatever the string is. What I want you to do is make a new method like bind array size, but print string in here, print string, call it what you like, define the method and paint the UI that I've given you in the challenge slide, this, okay? So as you start typing the word donkey, every key press, it updates and you get D-O-N, D-O-N-K, D-O-N-K-E, etc. And then because I finished on the word donkey, then lots and lots of updates went by, and that's why I've got 489 of those. So that's what I want you to do. Pause the video, see if you can make that happen, and I'll see you in a minute. Good luck. Okay, welcome back. So how are we going to make this work? Well, we're going to have a method called printString. Why are we making separate methods? Because it just makes life a lot easier. I want the GUI code up here to look very much like the actual GUI does. This basically says, you know, we always have update and apply modified parameters, but this very much says, look, we've got a fold out, and then we deal with the fold out, and if we fold out, which the if kind of looks like, then we indent, and that kind of, you know, it's pretty, just want it to look as much like the thing as possible. So print string is going to come under bind array elements. The good thing about this, by the way, is it means we can reorganize things. We can put them wherever we like, which is one really important reason to keep these things separate and functional, all of these separate methods. Okay, anyway, the first thing we need to do is find the text that is currently in this UI element that doesn't exist yet, whilst at the same time drawing that UI element. So I'm going to call it var because I'm not quite sure what serializable type is going to come back yet. I'm going to call it text, and then I have to work out how to do this. Well, it's on editor GUI layout dot. Now, what type of field is this? It's going to be a text field, right? Now, when you open the brackets, you'll see that you've got a few different signatures that you can use here. Okay, and we want one that gives us a label for a start and maybe some default text. But what are we going to use as the default text? Well, we've got to go and find that default text, the starting text. The first question we've got to ask is, what is the text over in the Camera Raycaster? We've got to go find this variable. How do we find that variable? Well, it's similar to what we did before with this find property, okay? So we're going to get back the current text, and it is something like serialize object dot find property. Now we've got to find the property path, and I'm going to guess that in this case it's as simple as string to print because it's just the name of the variable here. So string to print, that's what's being written in the text file, if you like. So then when we come to actually draw the GUI and store back what we got, we go text field, we give it a label, string to print, for example. And this is just a label. I could put a colon just so we can see that. And then we're going to populate it with whatever was in the member variable at the time. Now, current text is not the appropriate type at the moment. This needs to be converted to string. All right, with curlies like that. All right. Then out of that, we've got the text in question, and arguably we don't really need to even keep that. We could probably just say now, actually, I just draw it. Let's see if this works. There's kind of an intentional error in here, but let's see what happens. Let it compile. Here you go. Now, the string to print, we're getting Unity Editor.serialize property here coming back out. Why is that? Why is it printing that? Well, maybe it's my toString. There is another method from current text. It's called string value. String value as a property. Let's see how that works. Now it's blank. Okay, why is it blank? So if I type, it's blank. What happens at runtime? I start typing. Nothing's getting passed around. So what's happening? The string to print is blank. Why? Well, because we never change the current text string value. We go get it from the serialized object. We've already decided that having a custom editor script is messing up the default value that we set over in the code here. So what we need to do is we need to mutate this current text string value. So we say current text, let's leave a space so that it also completes properly. Current text.string value equals the result of whatever the user puts in the editor. So draw the editor, take the result, and put it into the string value, and then finish. And then next time round, you come back, you read the value, and you do it again. So you have to keep redoing the work every single update. Let's see how that works. Now, if we just play the game, and I start typing donkey, there you go. Every update here, it is printing to the console. All right, now I'm going to just show you the code that got written there, and then I'm going to rip the code out because we don't need it, all right? So print string did just those 2 lines there, simple as that, and you call it from wherever you want it. Now, I did say you can reorder these things. You could put print string at the top, and when you come back to the editor, this string to print will jump up to the top. So if you've got your code right in these GUI things, then your top level method should really just outline how the inspector's laid out, and you should be able to reorganize things. But I'm going to rip out print string because we simply don't need it. I am going to get rid of the whole method, and I'm going to get rid of all the bits that we put inside Camera Raycaster as well, all this stuff about string to print, because later we'll wonder what on earth that malarkey's all about. But hopefully you found that exercise, if not exciting, then instructional about how these editor scripts work. And you can see the benefits of them like this, and that we can work with on the surface layers, but ints behind the scenes. But on the disadvantages of the complexity that it adds is definitely worth keeping in mind. So I will look forward to seeing you in the next video.